Okay, we're looking at number 8. I have an equation with sodium hydroxide and sulfuric acid. We had 100 milliliter portions of each one of those at 24 degrees Celsius, and they're mixed. And we see that the temperature went up to 30.6, started at 24. We're not going to neglect the heat capacity of the cup and the thermometer and assume the solution of products density is 1 gram per milliliter and specific heat of 4.184. So our first thing we want to do is calculate the Q. So our Q has that heat capacity in it, has the total mass. I did this 1 gram per milliliter. I have 100 milliliter portions of both the 1 molar NaOH and the sodium hydroxide, or the sulfuric acid. So I have 200 milliliters altogether. And my final temperature is 30.6. And the initial temperature 24.0. 4.184 times 200 times 30.6 minus 24. I get, I'm going to have just two significant figures. The reason it's only two, when this subtraction here happens, that's going to be 5 point something, 6.6, just two significant figures. Alright, now on part B, we want to turn that into a delta H for this reaction. And all we need to do for that is look at that Q and relate it to the moles of, in this case, it wants to know the sodium sulfate produced. Alright, so I have a limiting reagent type problem in the sense that I have 100 milliliter portions, or 0.1 liter, of either 1 molar or the limiting reagent is the sulfuric acid. Now if you just think this one through, this one is actually kind of obvious which one's limiting reagent, and it's mainly because the stoichiometric ratio between the sodium hydroxide and the sodium sulfate is 1 to 2. So we're going to use up the sodium hydroxide faster, because if we look at this for the H2SO4, it's a 1 to 1. And just because of this, the sodium hydroxide is limiting. Oh, I guess I am just going to end up dividing that by 2. So to get my delta H for this reaction, I'm going to take that 5.5 we just introduced up in the part A, divided by that 0.05, the moles of sodium sulfate produced, and we got one more thing. Since this is actually producing heat, this is going to be a loss of energy for the reaction, so a negative delta H. So I get a delta H of negative 110 kilojoules per mole.